Hello, welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravindu. I am an assistant professor with ETC department, and the subject we are discussing in this series is object technologies and programming with Java. And the short topic and important topic that we are discussing from the last lecture and will be continuing for a few more is exceptions. Now, yesterday we have seen what are the exceptions, what is the basic idea behind the exceptions, and why it is important to deal with those exceptions. Now, we have seen in last lecture that if we leave our exceptions or if we left our exceptions to be dealt by the Java virtual machines, yes, the exception handling mechanism is robust with Java virtual machines, but the shortcoming is that our application will be terminated then and there as soon as an exception been encountered with. So you can count on that if an exception is being generated by your code, and if you haven't used any of the exception handling mechanism available manually, then you can count on that Java virtual machine is not going to resume the operations of your applications after handling that exception. That means it is going to terminate your particular application then and there after printing the exception name and a small amount of stack trace. Okay, now we have in last lecture we have seen how to insert the exception handling mechanism inside your code manually. That is, we will take control of the exception handling from Java virtual machine to in our own hands using the try catch block. Today, what we haven't seen in the last lecture, that apart from telling or handling the exception or writing some standard printout statements, we haven't anything done yet in that particular let's say in that particular code. So the idea behind exception handling is when any exception is being generated or thrown out of a particular block of code, it must be dealt with such that those exceptions should not occur thereafter, and if that is inevitable, then some alert messages or something else must be conveyed back to the user so that a few percentage of those exceptions can be avoided after that. Okay, so we'll see that in example, and we'll also see how multiple exceptions out of a particular try block can be handled. So I will head straight to the IDE. So I have already created a class, and let's start. So first I will display to you that how we can uh, alert the user about the exception, or how we can reduce the probability of the occurrence of these kind of exceptions after the first handling of my exception. Okay, so I will first initialize two data structures. So let's say access1, and I will assign some values to it directly. Okay, and it's up to you how you are going to initialize or declare your uh, arrays. It's up to you. You can either ask the user about the values, or you can just hard code those values like I have done here. It's entirely up to you. And let's now initialize the for loop. What I'm doing here, I will just discuss in a minute. Let me first write the code. And let's discuss. Let's start a try block. And inside the try block, let's first write a simple print statement. Let's write inside the try block. Okay. And next line, I will do some system some and let's do something bizarre, and let's say and I will divide it x2 and also okay. Let's write a catch statement first, and I will write arithmetic exception speed so and let's write the body of that, and this system and okay. Okay, now what I have done here is I have initialized a try block. Now this try block is actually inside this for loop. Now this for loop will iterate through the each and every element of this x1, because I have fixed the for loop iteration variable to less than the x1 length, that is 1 2 3 4 5 6 7, the 7 elements. And you will see I have tried to divide each element of x1 with the element of x2. Now as you can you must have figured it right now that at this particular index, that is second index, 3 is going to be divided by this particular element called 0, and that is an exception. We have discussed this in last lecture, that anything divided by 0 turns out to be infinite in mathematics, and that is actually not defined in our system. So it's going to generate an exception and it must be caught. Now there is going to be one more exception out of this try block, because the length of this particular array is not equal to the length of this particular array. Okay, so the length of xx2 is not equal to xx1. So there will be a time when this particular statement here will throw an exception calling index out of bounds, because xx1 is of more length than xx2, and when the value of I will exceed the value 4, then in that particular iteration the division will be xx1 5 divided by xx2 5. Now xx1 5 do exist, but xx1 5 do not exist because the length of this particular array called xx2 is just 5. So the index will start from 0 and end at 4. So its last index is 4, mind you. So this xx2 fifth index do not exist, and then you will encounter exception called index out of bounds. So I will not tackle that here. I will let JVM tackle that particular exception, but one of the exception called divide by 0 is being tackled by me manually here. So I'm not concerned about the other exception right now. Okay, so let's try to run this. Okay, it's as we have expected. We are inside the try block. We have printed the answer. Then we are inside the try block. Then you can't divide by 0. Okay, it means when this particular division happens, the exception is being caught by our try catch block. But the other exception, that is index out of bound, is not caught by us manually, and thus the the termination of our application happened then and there by Java virtual machine. So I think this is a problem because until right now we have only discussed a single try and catch block. If there are multiple exceptions, like in this case, encountered or being generated by our code block that is inside the try block, then how we are going to manage the multiple exceptions out of a single code block? Now there's a remedy for this problem because we are allowed to have multiple catch statements after a single try block. It virtually means that out of a single try block, if there are multiple exceptions being thrown out of it, then multiple catch statements or multiple catch blocks can caught those exceptions one by one and exclusively. What I meant by exclusively is one catch statement will caught only one type of exception, and that should not be done by any other catch block. So there can't be two catch blocks which let's say caught which catches same type of exception. Like in this particular example that you are seeing on your screens, if I write two catch statements with same type of catching same type of exception called arithmetic exception, then it doesn't make sense because both of them are doing same thing. So please be exclusive with that. So let's try to enhance our code here and try to catch the second exception, that is index out of bounds exception right here. I'll write catch and I'll write index out of bounds exception, and let's name it E, and I'll write the body and I'll write system dot out dot print ln, and I'll write like what should I write? I will write both of the data structures are not of the same length. Okay, so user must know that we are trying to divide each and every element of one data structure with each and every element of other data structure, but you must keep in mind that both of them are of not same length, so some of those divisions will not happen. Okay, are not valid, you can say. So I will try to run this particular code again, and okay, we enhance that. We will try to see what is happening. So as first thing first, you will notice that our application is not being terminated or was not terminated by Java virtual machines. In spite of that we have encountered multiple exceptions of different kinds. We have encountered multiple exceptions of different kinds, but each of those exceptions are being handled by us separately in separate catch blocks. So you must keep that thing in mind. Now, one of the exceptions has been caught here. You can't divide by 0. That is okay. Now, after some iterations, you will notice that The length of x2 has already been expired, so there is nothing to be divided by the element, or nothing is there to divide the individual elements of the xx1. Okay, so you will see that both of the data structures are not the same length. Then we'll again, the after this particular exception, the application is not terminated. We'll again go back into the loop inside the try block. We'll confirm that, and we have again encountered the same exception, but we have smartly tackled that particular thing also. So we have in total one, two and three exceptions thrown out of the try block, but we have smartly tackled each one of them, and we have ensured that our applications must not be terminated prematurely because of the exceptions that we have encountered. Okay. Okay. Next. Now, until now, we have seen that all the exceptions that is being generated inside these try blocks are actually not generated by us. Let me again say that all the exceptions inside this particular try block which I have highlighted are not being generated by us, but by the Java virtual machine or Java runtime environment. Now that particular environment is keeping the track of what is happening inside the block. When it encountered that the value of xx1 is finite, but the value of xx2 is not is finite but equal to 0, in that case it have encountered that I cannot solve this particular problem. That is, the compiler will encounter that you have divided a finite number with value 0, which mathematically will result in infinite number, but that infinite number is not being defined in Java or in the systems until now. So we must flag this particular event. Now, how is that flagging happens? That flagging is actually the exception that is being generated out of this particular statement. Now, that exception after the flagging of the event generated, I have discussed in the last lecture also that an object of class throwable, an object of class throwable will be generated, will be every time an exception is encountered. Now this particular event of generation of an object of class throwable or any of its subclasses, we have discussed what two subclasses are, so is not being done by us, that is being done automatically by Java virtual machine. But what if you want to do that manually? What if you want to do that manually? Now how can you do that? You can do that by using a keyword called from. Okay, so what must be the syntax? Let me remind you that again. What we have to do here is we have to manually generate an object of class throwable or any of its subclasses. If you remember the name of any of its subclasses or the subclasses of those subclasses, what I am trying to say is yesterday we have seen that throwable has a subclass called exceptions, and that subclass has a subclass called runtime exceptions, and that particular subclass called runtime exceptions has some subclasses. One of two you are using here. First is arithmetic exception, and next one is index out of bound exceptions. Okay, so these two subclasses whose objects are being captured here in the catch statement are actually the subclasses of runtime exception class, and runtime exception subclass is actually a subclass of exceptions class, and exception class is actually a subclass of throwable class. So throwable class is the superclass of all the exception classes. We have seen that particular hierarchy yesterday. So if you are not comfortable with what I have said, you can refer back to the yesterday's lecture. Okay. So what I will do here is I will remove these two blocks. Now if nothing is there, just a print statement, you know that we are not going to encounter any of the exception. Let me write that system dot out dot print ln, and if I write here inside the try block, if I write here something like this, then as you can see there's nothing in this particular block, in this particular try block, which is going to generate an exception. So these two statements must not execute in any case. But if we can generate an exception out of this block manually by the keyword using throw, we can actually we are going to actually generate an exception out of this block manually, and we will be independent of Java virtual machine exception handling mechanism completely. We will try to do that. First thing first, you have to throw an exception out of any try block. You have to use the keyword called throw. Okay, as you can see, it has been painted red by the IDE. That means it's a keyword. Now I will use new keyword. Now this new always signify that yes. Now you must have seen that in the previous chapters we have discussed earlier that new is always used to create a new object, and that is the main focus of our this particular line here is to create a new object. So I will write arithmetic arithmetic exception, and what is it? Oh, I must have yes, I must have messed up the spelling. Exception now. Okay, now it is right. Now what this particular line doing is whether there is something in this try block which generates an exception at some point of event, at some particular event, this particular let's say event or this particular line is going to throw an exception every time, because we are doing it manually. It is not event driven. Let me see that again. This particular line is not event driven. It is not being generated by a particular event, but intentionally it has been generated by you to see if manually we can generate an exception out of a particular try block or not. So let's try to run this. Okay, so you can see I have entered the try block, I have generated the exception. I have entered the try block again, I have generated the exception. I have entered the try block again, I have generated the exception. So every time, whether there is something or not inside your try block which is going to generate an exception or not, it is going to throw an exception, because you have hard coded that particular event in your try block. Okay, so this is how you can throw an exception manually. Now the question is, The real question is why I'm going to do this, why I'm going to throw something manually, but by the way, that is being handled by the Java virtual machine quite smartly. If your system is doing that, and that too with quite an level of optimality, why you are compelled or why we are compelled to do something manually? In which case, we can say that at any point of time we can mess up our code by writing just one wrong syntax point. Okay, so the point is, at the end of this particular topic or exceptions, in one of the few lectures I'm going to tell you how to create your own exception classes, your own customized exception classes. So for uh, let's suppose that you want to flag an event as abnormal. That means if you are dividing something by 2, you want to flag that particular event. Okay, divide by 2 is not allowed. Or my system is not capable of handling a divide by 2. And that is how you have written your application. That divide by 2 is not being uh, tackled by you in your code. So you will imagine if I have something like an exception class which can tackle this particular type of exception, that is divide by 2 exception, that it will be easier for me to run my application without the disruption of being terminated. So in that case, you will write a subclass, a customized subclass, a customized exception subclass, which will have the code to tackle the divide by two, let's say event or exception in that case, but your Java virtual machine doesn't know that you have written such a class. In that case, you have to throw that particular exception object manually, and you have to intuitively find out that, or to figure out that what are the possible code blocks where it is possible that an exception of divide by 2 can be thrown out or can be generated. Okay, so let me again iterate that. If you are trying to write an customized exception subclass which will handle or which will tackle a particular type of exception which has been not known to Java virtual machine but has been customized by you for your special needs, then those kind of exceptions will only be thrown out of your try block if you have written the code there to throw out those exceptions manually by using the syntax that I have just shown you here. Okay, so that is all for the manually throwing out an exception out of a try block. I will finish this lecture here, and tomorrow we are going to discuss the last two topics called finally, and how to, we'll see a small example of how to create your own customized exception class. Thank you.